Hi, I'm presenting today a new compressed air motor with a much higher energetic efficiency in comparison to many other pneumatic systems. The prototype you see here is realized with makeshift means, simple components, and can be realized with elementary tools. The simple experimental system validates, however, a technical and scientific sound principle. The main components of this motor are two pneumatic double-effect cylinders of different sizes or different volumes, here in the middle of the photo. The cylinders are coupled to a common crankshaft, where the crank pins are shifted of 180 degrees. You see them at the bottom of the figure. The motor comprises a distribution system composed of electromagnetic valves at the top of the figure. Here, a first video showing the motor in operation. In the foreground, you can see the position sensor which controls the distribution valves. Classical pneumatic actuators usually produce only so-called displacement work under constant pressure. At the end of the strokes, this means after the filling of the cylinders, the air under pressure is simply realized to the surrounding with all its energetic content. This represents a huge waste of energy if considering the amount of enthalpy transferred to the system. The displacement work at constant pressure can be represented by the rectangular surface in the PV diagram under the horizontal line at P2 and between the values of V0 and V1. In the new system, air is transferred alternately from the filled chambers of the small cylinder to the opening larger ones of the second cylinder, causing a thermodynamic expansion and adding to the output a significant amount of work. This amount of work can be represented in the PV diagram by the surface under the expansion curve and limited by the values of the volumes V1 and V2. V1 and V2 being the volumes of the respective chambers of the two cylinders. In the prototype motor, the ratio of V1 to V2 is equal to 1/4. A simplified calculation shows that the efficiency is nearly the double of the efficiency of a motor with only one cylinder and no expansion, the air consumption of both systems, of course, being the same. The next figure shows the operating sequences of the two cylinders. In the upper one, there are alternating phases of intake and transfer, this means expansion, while in the lowest cylinder, the transfer phases are followed by exhaust phases of the expanded air. In the upper and lower cylinder, the double effect piston chambers assemblies are working in alternance. Their movements are in phase opposition. We see again the motor in operation. You can see the alternating movement of the cylinders. The position sensor of the crankshaft gives a binary signal to the control and changes all 180 degrees in the upper dead center and at the bottom dead center of the pistons. In the next representation, you can see the motor working in slow motion. You can observe the horizontal guidance of the piston rods and also the connecting rods to the crankshaft. For those who are interested by such a realization, I'm giving some infos on the realization of the mechanics. For the axis and bearings, you can find in do-it-yourself stores some metallic tubes and bars which fit perfectly to constitute the bearings. You can see one crankshaft bearing at the right side of the slide. Little drops of oil will be necessary for longer operation of the motor. To realize the wooden rods and bearing supports, the metal tubes are inserted after drilling and glued with a two-component adhesive. The centering of the holes can be done easily with a selected drilling bit. For the realization of the position sensor, a ferromagnetic proximity sensor is used. The rotor is realized with simple means. A metallic part, just the metallic sector, the active sector over the 180 degrees, is glued on the wooden center. Finally, the electromagnetic valves, the tubing, the fittings and other parts are coming from the market. The valves are driven by a simple electronic circuit.